Alright, how are we doing today? We are going to start looking at trig identities today. These trig identities you were introduced to for the most part in Algebra 2, but we're going to do a bunch of verification with them today. So we looked at last chapter sine, cosine, tangent, and their reciprocals. And then we looked at tangent being sine over cosine, and cotangent being cosine over sine. We have our Pythagorean identities. Sine squared plus cosine squared equals 1. Then new to us is probably going to be 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. Now, in addition to all of these identities, I can manipulate them. For example, if I subtracted 1 from both sides, I would have cotangent squared equals cosecant squared minus 1. Right? And that works for all of our trig identities. So over on the side here, we have 1 minus cosine squared is sine squared. And 1 minus sine squared is cosine squared. We won't do a lot with even and odd identities. But we also looked at them a little bit in chapter 4. So if you need to get any of these down, pause the video and get them down. Once you have these down, then you can unpause and we're going to work through some problems together. So pause if you need to, otherwise we're going to start looking at them. Alright, so we're just going to do one problem. We're just kind of simplifying an expression that we have. So I have cosine x times secant x minus cosine x. We're just going to look at what that is. So when we're multiplying, things we're just going to distribute. So cosine x times secant x is cosine x times secant x. Cosine times negative cosine is negative cosine squared. Well, I can rewrite secant x as cosine of x times 1 over cosine of x. I do that because cosine x times 1 over cosine x is just 1. So I end up with 1 minus cosine squared of x. That should be one of our identities from above. 1 minus cosine squared of x is sine squared of x. So you could take and simplify the given expression just to be sine squared of x. So that's kind of what we're going to work at the next few days. Also, our verification of trig identities is kind of similar to what we're doing with proofs in geometry back when you took geometry. Right? So you're just trying to, you know where you're going to end up, you know where you start, and you're going to kind of do some math in the middle to get what you want. In order to do the math, we need to really know these identities. And hopefully, over the next couple of days, with you practicing a bunch, you will get a bunch of these identities. So I'll give you a minute, right, to copy these problems down, and we're going to walk through them. One rule of thumb, if you can, is to always just try and change things into sine and cosine, if that helps, or to recognize an identity if you see an identity. All right? So to start off, I'm going to look at the left side. I'm going to change secant to 1 over cosine. Alright? So I'm going to start off. Well then, sine is already in sine, but tangent I can rewrite as sine of x over cosine of x. Well, in this particular case, I have a common denominator, it's cosine x. So I can put these together and have 1 minus sine squared of x all over cosine x. Right? We're trying to get to equal the other side. Well, 1 minus sine squared of x is cosine squared of x. Right? So recognizing that identity. And then we know from there, if I have cosine squared over cosine, I can cancel one out. And I get cosine x. I like the little smiley face. And then we made my left-hand side, we showed that it equaled my right-hand side. So we verified that the two expressions were equal to each other. Or sorry, the two equations were equal to each other. The only way we get good at this is through practice. Every problem is different. Almost every problem you can solve more than one way. It's just kind of what do you see when you look at a problem. So if I look at the next problem, take a second and think of, do you see anything? If you don't see anything, then you just gotta try and start working on one side and see if you can get the other side to equal it. What I see right away is I see cosine squared plus sine squared. Well, cosine squared plus sine squared is just 1. So I really have cotangent squared of x plus 1. Right? Well, the nice thing there is cotangent squared of x plus 1 is cosecant squared. So if we recognize that identity, this is just a 2-step problem. And we're done. Now again, the only way for us to get better at this is through practice. Right? So we're just going to keep practicing, and then eventually you're going to go and try some. If I look at a couple more here, give you a second to get these down. Alright. Also, pausing the video, taking a minute to digest what we're doing is probably a good thing. So probably don't sit and go through like all 7 examples or 6 examples all at once. You should pause, take a break, look at the identities, see if you understand what's going on as we're going along. All right. So the next one, I'm actually going to use a trig identity just to be a little different, but you don't have to. Again, you kind of got to do some trial and error on which side you're going to start with. I did a couple where I changed the left side, so now I'm going to change the right side. And I'm going to rewrite tangent squared as a trig identity. All right, so now I'm going to recognize tangent squared is the same thing as secant squared of x minus 1. Okay? So again, a little tricky to recognize that. You will have to have these memorized when you take the Chapter 5 test, but that's not for a few weeks. Well, I'm now going to rewrite secant squared as 1 over cosine squared, because that's what it is. Well, from here, I'm going to distribute sine of x over cosine squared of x. Right? Oh, sorry, I lost my square. Sine squared, sine squared, and then I'll have minus sine squared of x. Well, sine squared over cosine squared is tangent squared of x. So again, we got it. At this point, maybe you want to try one, pause the video, see what you can do with the next one, and when you're done, unpause it, and then see what I did. Maybe you do the same thing, maybe you do a different thing. Alright, so I'm going to want to get my left side to equal tangent. Right? That's the set I'm going to work with. Well, I have cosine. I'm just going to keep using x instead of theta. Secant is 1 over cosine. Right? Do we remember that? And then I have divided by cotangent. Well, cosine times 1 over cosine is 1. So I have 1 divided by cotangent. Well, the reciprocal of cotangent is tangent. So I picked this one to have you do, hoping that you would find some success, because it's not quite as long as some of the other ones. We're going to do 2 more, and then we're going to take a break and have you work on some problems. Alright? So the next problem is I have sine over cosecant plus cosine over secant equals sine times cosecant. Alright? So I'm going to rewrite this a little bit. Divided by is the same thing as times 1 over. So I'm going to do the reciprocal. Plus I have cosine of x times 1 over secant of x. And I got to get that to equal my other side. Well, if I recognize this now, this is really sine of x times sine of x. And then this is really cosine of x times cosine of x. Because the reciprocal of cosecant is sine, and the reciprocal of secant is cosine. So I end up with sine squared plus cosine squared. Well, that equals 1. My other side, though, I don't have 1 yet. So I actually would have to get my other side in this particular case to equal 1. So I'd actually have sine of x. I would rewrite this as 1 over sine of x, because that's what cosecant is. So that is going to be 1. So this is the first problem where I actually had to look, and I had to change both sides. So 90% of the time we'll end up with working on one side, but every once in a while, we will have to work on both sides to see what we can come up with. Okay? We're going to look at one more together. So I have cotangent squared over cosecant equals cosecant minus sine. Alright? Well, this cotangent squared, I'm just going to point out one of the identities. Cotangent squared is the same thing as cosecant squared minus 1. Alright? So I point that out because I have a cosecant on my other side. Right? So again, trying to recognize some of these things as we're working takes some time, but if we know the identities, hopefully that will help us in what we're doing. So I'm going to rewrite sine in this particular case as cosecant. And I do that because I'm trying to get it to be cosecant. Well, now I don't have a common denominator. So I have to multiply the top and bottom by cosecant so that I can add it together. If I multiply top and bottom by cosecant, I'd have cosecant squared minus 1 all over cosecant. Well, that brings in what I had here. Cosecant squared minus 1 is cotangent squared. And what I wanted to get was cotangent squared divided by cosecant. Alright. So, this is very difficult. I would suggest, if you're watching the video, to definitely pause here. Do not watch the second part of 5.1 yet. I would do page 594, 1 to 33 by 4, and then, after you've taken a break, then maybe come back and watch the second part of the video and do the second part. So see what you can do with 1 to 33 by 4.